Thanks, everyone. My name is Simon Rascovsky. I am the CTO of Alara Imaging. I am a radiologist by training and biomedical engineer, but I moved over to the dark side several years ago, just informatics, and I've been doing that for over 15 years. Today, I'm going to talk to you about a class of products that doesn't get a lot of love, uh, somewhat understandably, but I think it's critically important in general for medical imaging, and in particular as we're moving towards cloud-based imaging workflows, and those are gateways. So as all of you know, cloud medical imaging journeys for healthcare institutions have accelerated in the past few years. This has been going on for a while. I remember being in several town hall meetings where there was a discussion whether people should move to the cloud. There were concerns about risk and what would happen if, somebody came and, had a subpoena on the cloud provider and removed the servers. All of these conversations have really just disappeared now. And essentially, it's now a conversation of when and potentially how medical imaging workflows are going to move to cloud. And specifically with machine learning, since the revolution of deep learning that started in 2012 and went on, where medical imaging became one of the poster childs of what could be done, that has broadened that the conversation, that landscape of moving towards cloud-based ecosystems. And some of these ecosystems are now becoming really mature and getting some cornerstone technologies, foundational technologies like AWS Health Imaging, that have products that are being built around them. So we see a lot of companies building viewers, machine learning tools, obviously work lists. There are migration tools that are designed to move information to the cloud, and also gateways. And that's kind of where we come in. That's kind of the focus of what we do. So medical imaging gateways, I've been deploying medical imaging gateways since 2007 for image sharing, teleradiology, and other purposes. And I can tell you, nobody likes them. I don't like them. It's a pain point. It really has been a piece of technology that has been done just good enough for the specific purpose. And we thought we could probably do something better. The reason why they don't get a lot of attention or love in technology is because to deploy these things is it's a bespoke process, very lengthy, difficult to integrate. The connectivity is typically very restricted to allow fluid management by standard means. Keeping gateways secured is really complicated to do, in part because of that restricted connectivity that is allowed. For the same reason, deploying new functionality is challenging. And for the companies that actually have gateways deployed, it's a pain, and it's a cost center, and it's challenging to manage several different gateways, many of them with different connectivity requirements. Sometimes companies have to manage 20 different VPN and VPN endpoints just to handle their fleet. So it's really challenging to do, and it's not something that people enjoy managing. So at Alara, for our own purposes, we needed a gateway, but we wanted a gateway that was easily deployable, that was going to be something that we could handle in a smaller team, and that had modern architecture and modern concepts around it. So we wanted it to be standardized deployment, low burden implementation. It needed to have security and compliance from the very, very basics, and to be able to accommodate really sophisticated security and compliance scenarios. We wanted to use cloud native technologies. We wanted it to be extensible and have extensive connectivity to many different systems within the site, and even have the capability to do some edge compute workflows. Obviously, like any other gateway, needed to be robust with self-healing, with observability to see what's going on, easy to manage at scale, and especially we wanted it to be multi-tenant. The reason for this is we wanted it to ease for healthcare institutions the complexity and accelerate the implementation of any particular feature from another vendor that wanted to use a gateway that was already deployed. So we made a number of architectural decisions on how this could be done. I'm not going to go through all of them, but there are some that are important. We definitely wanted to get away from the classical way of deploying gateways that required a direct connection with VPNs. VPNs were if I had to choose one of the features of older gateways that was the most painful of all was management of VPN connectivity. We wanted to get away from that completely. We also wanted to give a lot more visibility into the data transmission and the security of the gateway. And we wanted to try and make an impact on just how this could become less of a process-based deployment and more towards a software as a service type self-service product. So we did a number of improvements, I think, in the way that gateways are thought of. We wanted to modernize the entire product experience. So the architecture itself was redesigned from scratch. We even spent a significant amount of time thinking about what an onboarding process is for a gateway. So being able to facilitate the entire legal security review, technical implementation, training, document back and forth, BAA signing, all of that stuff. We actually wanted to make an impact on that pre-deployment process as well. So we generated a specific cloud-based client portal that manages all of the communication and document management and signing centrally, all the training and documentation for each step. Multiple team members get different nudges on what exactly needs to be done in the process to try and speed up the pre-deployment process, security reviews, configuration management, and so forth. We decided to put the security part of our product up front and transparent way so that security teams within the hospitals would be able to start getting acquainted with how we do things. The security review questionnaires that we get, we actually use AI to run through them based on a library of answers that we have on that trust center that shows what our security posture is. So we made a number of changes on that end-to-end process to try and move this from a project-based to a software self-service concept. The architecture, obviously, that we needed to use, it was pretty obvious to us that if we wanted to be able to manage fleets of these devices with a smaller team and be able to have real-time connectivity, be able to patch it, do updates and upgrades, deploy new functionality, and have observability and telemetry from all of them in an easy way. The architecture we needed to use was IoT. IoT was designed for this, handling hundreds of thousands of devices, being able to keep them all in sync, being able to have different versions of the software that they're in, being able to deploy things and have modest connectivity requirements via HTTPS, so you wouldn't have to handle VPNs or anything like that. With well understood security paradigms, IoT was the way to go. And so we designed the gateway specifically to use IoT infrastructure. In particular, we use IoT Greengrass. IoT Greengrass was extremely convenient and a very good fit for a use case because it is a higher level control plane for IoT where you don't have to manage the pure MQTT communication layer directly, and it allows you to use some of the more common software deployment paradigms um, to do more complex flows. So specifically, I'm talking about Docker containers. So being able to use some of the pre-defined containerized software components and being able to deploy them in an IoT way was very convenient for us. We can also obviously use any kind of software concept as a deployed component in IoT Greengrass. We can use lambdas, and we can deploy machine learning models for edge inference, which is going to become more and more important as we have models that are dependent on latency and or have some specific privacy and security concerns that we want to run at the edge. So we wanted to have all that flexibility to run all of these workflows within the gateway, and IoT Greengrass allowed us for that kind of functionality. And it also has other advanced functionality, specifically one of the ones that made the difference in our choice of IoT infrastructure was the capability to do SSH over HTTPS. Sometimes, no matter how robust you make your software, you still need the ability to do direct connectivity and debug, but you do not want to ask the site to open up an SSH port or a VPN. We're trying to get away from all that. So being able to do some of the SSH specific debugging capabilities over our standard HTTPS connectivity to the gateway was absolutely critical, and that was one of the differentiators that we were looking for. So this is a general diagram of kind of how our gateway is put together. We deploy inside a VM in the gateway in the inside the firewall in the healthcare site. The gateway consists of the IoT Greengrass IoT management layer underneath. We have a very powerful task and data orchestration engine inside the gateway that allows us to have many complex workflows that tap into the different components that we're able to deploy to do things like obviously the ingestion, metadata extraction, harmonization of the data, then shared compute modules that do things like de-identification, specific custom framework modules like what we do for our own purposes in Alara of electronic quality measure, computation compliance, some things that have to do with computer vision, and then additional customer compute modules that can be deployed to the gateway. We ingest data from different feeds. So we have EHR data connectivity bidirectional with FHIR and HL7v2. We can tap into more traditional systems that use tabular data like CSV, Excel, and CLF, like billing systems. And of course, being an imaging company, and this being more of an imaging-centric gateway, we have full connectivity with PACS and modalities via DICOM. One of the things that you'll notice here is that in that top box on the right, you see that our Alara AWS cloud environment is dedicated to IoT operations. So this is a differentiator, we believe, with most of the vendors out there that manage platforms where they do extract data from the healthcare sites and send it over to the cloud and then distribute the data from there. We only manage the pipe. So we do not touch the data for our clients in our cloud. The data for our clients in the cloud only goes directly from the gateway to the client's cloud infrastructure directly. We only manage the monitoring, alerting, security, malware detection of the gateway itself, and we keep it operational and performant. But the data, specific PHI data that they are going to extract and use for their own purposes, does not go through our cloud environment. It goes directly to the client's infrastructure. This is good because it facilitates the way that the clients generate their contracts with the hospital and gives everybody kind of peace of mind that the data is flowing only between that relationship between the two. Um, because of our ability to connect, since we were born out of AWS components, we also have the ability to trigger workflows within other AWS managed services. So in this middle box right here, you see that we are able to send over data to a client's S3 storage for staging, but we are also able to trigger the ingestion of that data to health imaging directly from the gateway. So we don't need a direct communication from our cloud to their cloud. The gateway itself can trigger some additional AWS managed services without having to go through our cloud. One aspect that I'm going to touch briefly here is why we're doing this as a multi-tenant type platform. We're trying to reduce complexity at all levels. And sometimes when you try to reduce complexity at the vendor level for these types of software as a service, you end up in increasing the complexity for the source. In this case, the healthcare institution. So we tried to make this multi-tenancy so other vendors could actually land in previously deployed gateways and have the healthcare institution not increase their complexity or have a number of gateways that they need to deploy. So if we take the case of a simple scenario with a vendor deploying a single gateway in a healthcare site that requires PACS and EHR connectivity, it's relatively straightforward. PACS and EHR both connect to the gateway sends to the vendor's cloud infrastructure, and that's the end of that. Once you add additional vendors, that site now has to send the data from their PACS to three different gateways, from their EHR to three different gateways, and then three different outbound connectivity endpoints to the different clouds for the different vendors. Already, this is becoming more complex. And if you think about it in the broader sense of multi-site organizations with multiple vendors, then it becomes really, really complex and very inefficient, where you're sending the same data repeatedly to gateways that eventually are going to deliver the data to a single cloud over and over again. And then there's a lot of deduplication scenarios that need to happen. So this diagram that you're seeing here, you can multiply this by 10, by 20, and you can see how complex this can actually get. So what we tried to do is make sure that our gateway was able to accommodate multiple vendors within the same gateway as they have the same types of needs for data feeds and are able to receive data to their individual clouds, and the data gets routed in a way that is transparent to the site and also much more efficient. So in this case, you can see there would be just one single EHR and PACS connection to an Alara gateway that can then send to the different clouds no matter what the vendor is. So in general, the benefits of this and the other kind of architectural decisions that allow for this rethinking of gateways is that medical imaging departments can know who is connected to their data and simplify that edge to vendor cloud vendor strategy. There's more transparency in how they can see what data goes where, and they can ensure that the data is delivered to their proper destination in a verifiably secure way. And for healthcare technology companies like AI companies that are coming up in particular, it's very useful to have a outsourced gateway as a service product because they can refocus on their core competency. Typically, machine learning companies that are coming out are companies that are born out of data scientists, data engineers that are very focused on improving their models, improving their MLOps. They were born off the cloud, and all of their workflows are in the cloud, but managing the HIPAA, SOC 2, high trust, connectivity, interoperability, and security requirements of deploying gateways is really quite challenging for them, and it becomes a cost center. so they can refocus on their core competency and accelerate their deployment and security reviews when they are going to deploy. They can transform the data before it arrives to them, so they can get a reduced data set that they can process more efficiently, and they can build the cloud native solutions with a purpose built edge to cloud infrastructure without having to worry about all of those complexities. We are built on Amazon Web Services, and we can interface with any of the managed services that AWS has and trigger them directly from our gateway. So the key takeaways that I want you to have from this talk is that medical imaging gateways are a key piece in cloud environments, cloud-based imaging workflows, and many times this is the single most important pain point that companies have. Um, Gateways are typically quite complex systems, both from an interoperability, security, and scalability perspective, and they can easily become a cybersecurity risk because there's no easy connectivity to them, and people just don't want to do a lot of touching of those machines, which can increase the risk that they are not patched in a timely way. But there are many things that we can do to modernize and secure gateways from how it has originally been done. We can use modern architectures like IoT to facilitate the deployment and the management of them. Managed gateways can help cloud-based tech companies refocus on just what their core competency is and how they should be using their resources, and kind of allow that complexity to be outsourced to somebody that does just that for a living. And managed gateways can also help hospitals reduce the complexity of having 40, 50 different gateways, as there are many companies that are coming up with best of breed products, but they need to deploy their own gateways themselves.